Hi everyone. Thank you very much for coming. My name is Alen Ladavac and I work at Croteam, which is a veteran game development studio based in Croatia. Today I'll be demonstrating some of the tools that we use in production of the Talos Principle. This talk touches on some of the subject that Alexander talked about 2 sessions back, but it's quite different and I hope you will like it. First, a little bit about Croteam. Croteam as a team has existed for more than 20 years. We've made many games, starting way back on Amiga, making football simulations, and then we made a whole set of the games from the Serious Sam franchise on PC and various consoles, and most recently we created the Talos Principle, which we shipped for PC, PlayStation 4 is on the way, and on Android. All this time we never grew over 25 people, and we like it that way. We like to be a small team. We think that we like working in a smaller team better. In order to be able to do it with such a small team, we made sure that we have best tools that we can make to help in our process. In this talk, I will show you what these tools are. We show you how we use them. However, there's not enough time to talk about how we implemented each of them. However, most of those tools are not very complex to implement. And what's important that I want to show with this talk is that you have to set your goal to optimize the process and create the tools accordingly. But before I go any further, most of us know that process optimization often conflicts with people who want to do things ASAP, which is also a valid goal, because you have to make a game in the end. There's internal struggle between 2 people on the team, one who wants his salt right now and the other one who wants to make a system for arbitrary condiments. Also, sometimes it can happen in your own mind. I often find myself thinking, should we automate this or should we just do it and save time by not automating it? How to resolve this kind of conflict is something that I want to mention a little bit after I show you the examples. So let's get started. This is going to be a stage example based on the Talos Principle, but it applies on other games as well. Here I've deliberately introduced the bug in one of the levels of the game, and I'm going to walk you through the development cycle about how we detect and fix and ship fix to that bug. So first, here we see a tester is playing the game. His primary goal is to test how the playability of the game works, how to test of the puzzles, but he often notices some problems like this visual issue here, where the shadows have obviously been baked wrong on this piece of rock. Now the question is, what should he do? Obviously, he should report the bug, and there's various methods. People used to write it down on paper, alt-tab into some bug reporting application. But whatever they do, it takes a lot of time to describe how to reproduce the bug, and it gets boring to people, so they like to skip that. Obviously, you want to know where your bugs is. And we try to work on improving that. So this is how it looks for us now. I don't know how much you see here, but basically it's just this is what we call the world bug system. It helps us report the bugs directly inside the game world. It's literally, as you saw, just one key press and type a short description, and off you go. It's under 10 seconds to report a simple bug like this. And the best thing is that the position that you were standing, where you were standing, and the position that you looked at, where your crosshair pointed, those are stored automatically by the system, and they can be replicated when the designer goes to fixing the bug, which helps tremendously. Besides just reporting those bugs, you can use the same system, as you will see now, to immediately look over other bugs in the same level. You can replicate the position. As you see here, I see at the bug that's been reported from close-up, and maybe this bug is visible only from far away. And this is our bug here, and we can modify some things in the bug, like reassign it to some other person or mark it fixed or something. But here now we're going to switch the roles. As the tester has reported the bug, now we're going to watch over what the developer does when he comes to work in the morning. First thing that all of them usually look at in our team is what you call the build monitor. It shows status of various continuous integration tools that we use. It shows all the builds, integrations, and it's also a central place to install fresh tools or fresh game builds, so everyone's is up to date every time. This is the bottom part of it. Shows a list of recent changes. It shows which builds include which changes, and in case some of the changes broke a build, then you can see this red line here with the bug reported with complete log of what failed in the build. So all the bugs get fixed ASAP, so they don't linger in there. You can also see, I don't know if you see the small green check marks here, which knows that this particular change has passed some quick consistency checks. Like, for example, if you submitted a model, all the textures that are referenced by this model have to also be submitted in the same changes or before, so that some of the build bugs we try to prevent in advance. Now this is the upper part, which is usually most important. These are the most recent builds for each version. Right now, as we are going to fix some things in Talos Principle, we're interested in Talos for the PC version, and we're interested in the developer tools for Windows. We just click on the setup link here, and a small setup application pops up, which is designed to be very quick. It will very quickly install all the necessary tools, the latest build of them. It will also sync all the latest content from Perforce and immediately launch you into the tools, so that the designers have very easy workflow in the morning. You just click on this, and in 1 minute they're directly in the editor. They know that everything is up to date. So here, after we installed and started the editor, we can go around. We're in the same level. We can go edit stuff. But what's most interesting for us now is that we're going to fix some bugs. So we're going to open the World Bug System Explorer, which is the counterpart of what the testers see in the game. You see the same list of the bugs here. And we're going to see some of the same bugs that we saw in the game and replicate exact positions, so in case something is wrong, we exactly see what the player saw. Now go back to our bug here, which we definitely can confirm that this is wrong, as the tester has reported. And it's probably something wrong with the shadow UV map. So we're going to go into a mesh editor. And what's interesting to note right here is that here what you saw is the content editor that we use. It's a central hub for about 90% of our editing needs. We prefer to have in-place editing of as much content as we can. Meshes, shaders, animations, and as well as in-editor playtesting, which simplifies some very usual workflows for designers. For example, I cannot jump over this gap, so this ledge needs to be closer. You just move the ledge, you can move vertices or whatever, and within seconds retest it whether that worked correctly or no. You don't need to re-import something from external tools. It doesn't mean that we don't use any external tools. We still use them for character animation, for some more complex mesh editing, for texture creation, and various other things. But about 90% of time, most of the level designers spend directly inside this tool, doing everything. So let's get back to this mesh editor, where this, you see where I've deliberately moved these UVs outside of the range. I'm going to fix that and exit from the mesh editor directly back to the level. See how that looks. It's still not quite correct because the shadows now need to be rebaked. So I invoke the global illumination solver dialog, which is another tool that this one I mentioned at the beginning that most of those tools are pretty straightforward to implement. This one is quite complex, but we had to do it in order to save time. As you know, most engines today use various ways of global illumination ray tracing to calculate realistic shadows, and it can take hours to process often. In this case, we didn't want to change to using GI in our engine until we were able to come with a system that uses GPU for processing, so it cuts down this baking from hours down to minutes. Exactly how it does that, it's not that complex, but it's rather complex to explain. It would probably take another talk. So for now, let's just say that it also runs on separate Baker machines. So we need about two of those machines with super beefy GPUs, usually about 4 gigs of RAM for each, GPU RAM for each. For a 25 people team, two of those are more than enough. And while it bakes, developer can work on something else. So we try to shave off as much time spent as possible. So after I clicked OK in the dialog, it started baking. You can maybe see in the lower right corner, it's a bit out of the screen, the progress bar as it's baking. While it bakes, I can go around, edit various things. It's important that I obviously don't change something that will influence the bake shadows, otherwise I'm going to have to reissue the bake. But when it's done, the editor is going to automatically import it back. It does take a few minutes, about 5 for this particular level, so I skipped that part of the movie. And after it's baked, you can see that it's correct now. And the only thing that's left to do is to mark this bug as fixed. So, but we're not going to just mark it as fixed. An important detail is that we will connect this bug to the exact change list, where I will also submit the UV change and the newly rebaked shadows. I will submit it all in the change list that will be connected to the bug, which means that the testers will not really see the bug as fixed until they sync to the latest content. Otherwise, you get a lot of false reopening, like you said it's fixed, it's not fixed. So this prevents this problem. As this has been checked into Perforce, we come back to the build monitor and see that various other different builds are triggered by this submit. But what we're most interested in is what the testers will now recheck is this is the Talos PC final from the Talos branch. And as that build completes, the next build, let's say, it's actually an automatic test that starts in Cascade after it. It installs this build and tries to test it. And it looks somewhat like this. So here we have a bot that automatically plays the entire game. It has like basic logic recording from the game where it records how the designers played the puzzle originally to test it. So it knows which item goes where in which order, so that he can solve all the puzzles in the game completely automatically. And this bot can play the game from start to end. It doesn't really prove that there are absolutely no bugs in the game, because there can always be some other corner cases. You can do some different things, and there are going to be visual bugs that the bot cannot detect. But it proves that you can start the game and play to the end without having any crashes. And you know that there is a way to be complete, for the game complete. There's no 100% blocker bug in the content, like some puzzle is not solvable. But it doesn't really look exactly the way I showed it. It looks more like this. So it finished this puzzle in about 6 seconds. So this is super fast automated testing. Normally a human tester takes about 10 hours to finish the Talos Principle together with all the secrets, and that's a human tester who's done that numerous times, so he knows everything. The bot can do it in about 4 hours of game time if you don't play in fast forward, because the bot has a perfect navigation. He never gets lost. He never makes any mistake. He's not distracted by other humans talking to him and things like that. So, and in fast forward mode, the bot can complete the game in about 20 minutes, which is great. And that together with the relatively short automatic build time, we've come to the submit to tested time of less than 1 hour. Which means that from the time that I've submitted this change list, within less than 1 hour, I'm 100% sure that this build is installable and playable from start to end, which frees the designers and programmers a lot from fearing that they will change something that will break something in the game. You know, you change some model, it's used in who knows how many places, or you change something in the physics, or whatever you do, you never know if you're going to break something. With this, you only have to wait 1 hour, and you know that you didn't break anything catastrophic. Maybe that something looks wrong, but the game can still be finished. Overall, it clocked in at about more than 15,000 hours of man-hours of human testing. which would mean that we would have 8 humans employed for, because this phase lasted about 1 year, we would need to have 8 humans employed, which is not something that we could afford in this kind of team. And it helped us make the game on time and with much more iteration, much more changes that we would be able to use otherwise. Now, as I showed you all this, I would like to talk a bit more about this, what I mentioned in the beginning, resolving the conflicting goals. All of this obviously wasn't implemented in one go. It was a long chain of gradual improvements. We started doing this way back from earlier Serious Sam games, and we improved it from project to project. And the key, I think, is to avoid doing a lot of at once. If you start doing, like, I'm going to make this super great tool that's going to do everything for you, then you're probably going to spend months there, and the rest of the team is going to say, no way, you have to implement some other features for us. So we try to make small steps that work. Even the bot and the automatic and the bug reporting system, none of that was implemented in one go. Bug reporting system was very primitive in the beginning. It didn't directly interact with the bugs. You had to export files here and there. But we improved it over the time until we get to this stage. And each small step needs to have something important, so that the rest of the team are going to say that the tools programmer is doing something useful, not just blabbering about some automatic tools that are never going to work. So I like to talk a little bit about more about why we do this. There's obviously long-term savings in time, that's as the guy from the comic from the start says. But it's not only about that. Menial tasks should be done by machines, even if you don't save any time, because humans don't like to do repeatable things, even if they can maybe be quicker than a machine if you take all together. Besides just helping with repeatability and avoiding human errors, it also avoids frustration in developers. And if developers are not frustrated by doing all the same re-imports on the installs and everything every day, they have more mental energy to work on more useful things in the game. And finally, as maybe someone who saw the previous lectures, there's always, everyone has their own approaches, and everyone comes up with different tools that they can automate things, and there's always more to do. So this is by no means intended to be like a complete overview of everything that we do or everything that could be done in various different ways. Thank you very, very much, and I think we have about 5 minutes for questions.
Are there any questions?
Thanks for the good talk. With your bot testing, how do you handle when it fails? So if you're on fast forward mode and it's playing through a level, what does it return when it fails? Just basically.
You mean the bot?
Correct. Yeah.
Yes.
Obviously, you know when it's successful, but how do you return when it's failing?
So it's also integrated with the world bug system. As I said, it's quite short time to talk about everything. It's integrated, so if it notices a smaller bug, like it tests for things like he saws like this item is supposed to be on a wall, but it's actually inside the wall or outside the wall, it will tag it with the bug, with the world bug, as a human tester would. And if it happens that he cannot, for example, this door won't open, he's going to tag a bug there, he will jump through the door. So at any means, it tries to go to the end and report all possible problems as much as possible.
Could you elaborate on how you instruct the bot how to play the game?
When the designer thinks that he's got a puzzle that works, there's kind of like a recording tool that you press. You said, bot starts recording this, and then you play the puzzle. So the bot doesn't actually completely record everything. It's just like you use this connector to connect this source to this target, and then you go to this door, and then so it records the basic logic of the puzzle, and then it can repeat it. If you move some things, it's going to walk around because it has a level navigation, but it doesn't try to figure out the puzzle by itself. There's no way to do that yet.
And how much development time is devoted to extending this editor to have all-in-one solution?
Well, it's been like this iteration of editor. It's been existing for more than 10 years, so it takes time. I mean, we had a first one. It was very similar to that, and it was done in, I don't know, maybe it was way back in 2000. It was done in several months by 2 programmers for the first iteration. Right now we have about 1 person who's doing this full time out of, I think, I'm speaking from the top of my head, 6 or 7 programmers who's doing full time, just maintenance on the editor. Just I need this new tool. This doesn't include, for example, the bug system. Once we get the bug system up to some level that we thought it was useful, then we had 1 person just revamp it and do all the fixes to make it like a solid tool. Previously, it was just like I do something for a few hours, and then it does something and improve you for a few hours. And then after several iterations of that, we say like, okay, this is a really good tool, and spend some more time on that. The test bot was also iterated several times. It took 1 person, I don't really know, but maybe several months to implement that in several stages.
Okay, thanks.
Thanks. Out of curiosity, did you have, while designing the levels, did you use this procedural code and everything to propose some of the design, or was it made by trial and error, and then after designing some of the levels of the puzzles, they were tested by the bot?
You mean, no. The puzzles were first tested by humans for maybe do they make sense? Do people love the puzzles? But once they say that the puzzle is good, then we just have the bot handle, like the menial task, or did something break? If that answers your question.
Yeah, I was just curious if you use the procedurals in advance to create puzzles, not from the human.
No, everything is handmade. There is no procedural generation at all in the game.
Great, thanks.
All right. I think we have time for 1 more.
How do you usually handle the situation when you've changed your asset in-game, in engine, and then your artist changes something in your source, and it's obviously out of the sync with that which is an engine? It's
usually the same artist, and they can import and export in both ways. Some of the assets don't even have, for example, a lot of those like mountains and rocks. Some of them don't even have the external because they were made from scratch in the editor. They don't have the externals, but you can create them if you want. For things like trees and character models, they're created in like Max, Maya, or Modo, and then they get imported, and they know that if they change on one side, they have to export in the other direction, and vice versa, so they keep it in sync.
Thank you.
Thank you, everyone.